what I'm going to do is tell you a little bit about some of the key lessons that we learned along the way, and hopefully that will be of some use to you as well. So Highspot was really founded on, at least from my point of view, other people will have different points of view, but from my point of view, it was really a couple of questions that really sparked the whole thing. And the first one is, if you're at home and you're with your kid, and you want to find a viral pet video, for example, you will use the best technology that humanity has ever built. You'll have an amazing experience you'll find in 30 seconds. If you go to the wealthiest companies in the world and you're trying to close a $50 million deal and you need a white paper, pretty much God help you. So that seemed like a missed opportunity. And if we were to solve that problem, why then surely we would have a wonderfully successful company on our hands, right? So that was sort of the foundational approach that I took for Highspot when we started. So how do you solve those problems? Well, obviously, machine learning is going to make this a simple problem to solve because, I go to Google and I type in a phrase, I find it, right? I go to Amazon and I'm looking for an item out of millions of items. I find it immediately. How hard could it be, really? And then, of course, once you did that, obviously you were destined for business glory. Well, sort of. So an interesting data point is Google. So it turns out Google's actually pretty good at search. They basically forgot more about search last Tuesday than most companies will ever know in their lifetime. And so they had this product for quite a while, actually, called the Google Search Appliance, which was designed to solve the enterprise search problem. And it didn't work very well. A couple of people on my old team worked on the product, and they were super sharp people. And of course, Google knows all this stuff about search. And yet they went into this problem of solving the enterprise search problem, and they didn't. And in fact, they discontinued the product. And it wasn't a particularly good search engine. Now, if Google can't solve a search problem, you got to ask yourself, there's something going on, because it's got to be a pretty hard problem, right? It's just maybe they just had a moment, a glitch where they lost their minds and forgot how to do search, but I'm pretty much going to doubt that. Actually, what's probably going on is that the problem that they're tackling is for some reason a super fundamentally hard problem. And it turns out it is. And we have made, we think, some really great progress on solving it, but we did it the way that we were taught to do it in computer science, which is if you have an unsolvable problem, reframe the problem. And so I'm going to talk a little bit about that as we go. But I'm mostly going to talk about some of the learnings we had of how we learned to apply ML in a successful way in a business context. OK, so we built this solution. Now you can solve this problem. Who could resist buying this wonderful product that we had created? Well, it turned out lots of people could resist it just fine. And there were a couple of main reasons for that. One is that we solved a problem that was only part of the problem that the customer cared about. And the other problem was that we framed our solution the wrong way for the people we were trying to sell it to. If you go to a marketing person and you say, guess what, great news, I've solved your search problem, they will look at you funny and say, I don't have a search problem, I have a selling more stuff problem. Why are you talking to me about search? That would be the IT person down the hallway's problem, go talk to them. So in addition to figuring out how to solve the technical problem, you have to solve the user's problem, and then you have to solve the business problem of how to get people to care. And unless you solve all those problems, your work is not going to make any difference. OK, so we solved that problem, and we figured it out. We have lots of cool customers. We're super grateful that these companies are betting on us to run their sales efforts, which, of course, at any company is going to be the lifeblood of your company. So what did we learn along the way? And I'm going to just share a few of insights that we came to, so you can spare yourself the 7-year journey and get it all in 30 minutes. So first thing that we realized is that you have to start with customer pain. And you want to try to avoid starting with this really highfalutin concept of customer pain, like you have a search problem. What you want to do is get super granular and go with users and figure out what is the thing that just annoys them. we call it the pebble in the shoe. It's not the grand strategic vision of their future potential. It's, I can't find this darn case study, or I'm trying to put this piece of content in this system and I'm having a miserable experience as a publisher because the system won't let me put it where I want it to or create the experience for my users that I want. So you've got to ground it in like super concrete things. So here were a few. I won't go through them all in detail, but you've got to really sit down with your users, and you want to not have high-level conversations with execs. You want to sit down with someone who's actually doing the work and batter your head against it with them to try to make sure that you really understand what's going on in your users' minds. Then you now understand their problem. Now you want to make the customer successful. It doesn't matter if your algorithm is good. Nobody cares if your algorithm is good. They care whether you're solving their problem. And to solve their problem, you want to have really good design, because if you make it really unpleasant to use the software, no one will use it, and it doesn't matter how good your algorithm is. So design is actually a crucial part of making ML successful. And you have to do the touch of magic. That's what our little fun phrase for the ML part. And then you actually have to partner with your customers. Now, this is different in a consumer world, right? Like Google, when you do a search, isn't really doing a deep human partnership with you. But in a business context, your business people want partners. They want to talk to you. They want you to be an expert. They want you to help them. So it's really important to embrace that and not avoid it, which a lot of companies do. OK, so we went off and built a lot of cool stuff. We built classifiers and clustering systems and collaborative filtering and NLP and all this good stuff. But in the course of figuring out how to use all this neat technology to actually solve problems and drive business value, we had to learn a few lessons. So let's take a look at them. So to start with, machine learning is not some abstract theoretical exercise. Machine learning is getting down into the mire and the mud and banging your head against the data. So when we were starting out, we had a really senior person from the ML community who had been on the very senior person on the Bing relevance ranking engine. He knew all this great stuff, all this beautiful information. And we thought he would come in and he would sit back and he would listen to us talk about our problems, and he would smoke his pipe and he would point it at us, and then he would give us sage and deep wisdom from the ages. That's not what he did at all. He said, give me your data. And he started banging on it, and he started poking at it, and he started looking at its quality, and he started tossing it up in the air, and he put it in different tools. And what was most frustrating for him is that he wanted more data. And so a key lesson I learned is that you don't know anything until you actually get in there and start banging your head against real data and trying things out. All the theory in the world is not going to get you anywhere. You've got to get in there, and you've got to actually really confront the data and work with it. And it turns out that this was a kind of a learning for me. So my background's in systems like compilers and operating systems. That's what I studied in graduate school. And so I had a little bit of stats and OR and stuff like that. But back when I was a grad student, ML wasn't really the thing like it is now. And so I came at this as a relatively inexperienced person. And one of the really interesting findings is, boy, there's a lot of algorithms. And there's a lot of different flavors. And you know what? They kind of all work pretty well. And so again, what I was expecting our sage and expert ML person to do was to come in and say, I have thought deeply about your problem, and the perfect algorithm was forged in some Hungarian, cabin somewhere by some amazingly expert person, and it's published in the dusty archives of a place that you don't know about, and here is the algorithm. And then he didn't do any of that. He started using the kind of stuff that I was learning about in my Coursera class when I was, sitting there listening to, Andrew Ng tell me about machine learning. And he was like, oh, let's try, some logistic regression. I'm like, but that's like for children. Isn't there some like super fancy, amazing thing you're going to use? And he was like, nope. And so the key thing that I learned is that great algorithms can tweak you on the margins, but at the end of the day, a pretty good algorithm on better data is always going to win. And so that was a really interesting learning for me, how important the data was. And the problem with enterprise data is it sucks. So you think about like an enterprise, and let's say it's a 10,000 person company. They have 2,500 sellers. Those 2,500 sellers are sending, let's just be generous and say they're pitching their customers 10 times a day, right? So think about how much data they're generating, right? That's 25,000 pitches a day. Well, you know what? It's almost 11, which means that Google has probably hit their first billion searches today. So the amount of data you get in the enterprise is pitiful by comparison to what people are used to in consumer world. Now, obviously, there are certain kinds of enterprise activities that are a little chattier, but mostly it's like this, right? Mostly what enterprises care about is business activities done by humans with other humans. Well, humans are kind of slow, and if you only have 2,500 humans, there's only so much activity they're going to generate in a day. And so the problem with enterprise data is there's not very much of it. And it's noisy. There's all these annoying outliers. And so it's super, super easy to overfit. This is one of the biggest problems that you have with enterprise data. Because you have so little of it, you're like, aha, if I send this case study to red-haired, left-handed CEOs, I always get the sale, because you did it once. And so the problem is you don't get enough data to generate really good insights, or a lot of your insights are spurious insights. And so what it turns out that in this space, at least our finding was, you have to do what we call combining art and science, which is our little tag phrase for basically saying you need people in the loop. And so people are pretty good at looking at a supposed insight and saying, nah, that's not an insight. And so it's very important that you do all the cool ML, you do all the cool work that you want to do, but then you allow humans to curate and put their insight in as well. So it's this combo of humans and algorithms that gives you the magic. Another thing is that sometimes you run into people and they're like, okay, I'm going to buy me an ML and I'm going to bolt it into my product and then I've got ML. That doesn't work at all. Probably most of you know, but for those of you who haven't had this experience yet, in order for you to get any value from ML, you've got to actually get in there and mess around. And a lot of the things you try won't work at all. And so it's this constant experimentation loop where you go in there, you try something, you throw up on the wall, doesn't work at all. You go scratch your head, you look at the data, you do it again. And so it's an ongoing activity, and you cannot outsource it. This is not a thing that you can outsource if it's a core part of what your product does. You have to go in and do the work yourself. And you're never done. You're always going to be iterating. The world's going to change. You're going to get smarter. You're going to get new kinds of data. One of the realities of business data is it's very federated. So you're going to get data from all kinds of different places. And when a new source of data suddenly emerges, well, first of all, you got to cleanse the heck out of it, right? Because, oh, they use different time scales. They have, the data doesn't join properly. The keys don't match properly. You have to, it has weird outliers and noise in it. So every time you get new data, you first, you're super psyched because you have new data, but then you have to go clean it up. You have to align it with the data you already have. You then have to update all your algorithms, and you have to go do it all over again to try to figure out how to get smarter in an interesting way using that new data. Another big thing, and this was really crucial, is that mostly doing nifty ML and presenting the results to your users is useless. Because most of the kinds of insights you can generate don't matter. So the key thing was to find where exactly it's leveraged. And sometimes we got that right. Sometimes we got it wrong. And sometimes we only discovered it after the fact. So let me give you an example of all three. So where we got it right, search. Obviously, search is crucial. Approximately somewhere between 40 to 60% of item views in our system are derived from search, and the other half are from browse. So they both matter. Both modalities of finding information matter, but search is crucial. We knew that right from the beginning. We were right about that. There's one where we were just completely flat wrong. So I'll tell you this story because it's kind of a fun story. So So we had heard from lots of our customers that one of their concerns was that sellers should know the latest news about their customers so that when they call up their customer, they're like, hey, I noticed that you guys, had this big win or are wrestling with this issue or whatever. So you're like smarter, you have these great conversations with your sellers. So we said, okay, this is clearly a problem. Note, we got this from like kind of a top-down, wouldn't it be nice, not from like someone who actually sold for a living saying, I need to solve this problem, right? Okay, so first warning sign. So we then went off and we built this super cool ML infrastructure, and it worked beautifully. It did semantic analysis, and it watched which news items you looked at, and it like it built classifiers, it had per team classifiers, had all this great technology, and it actually worked really, really well. You could feed in a bunch of random news feeds into it, and it would quickly train itself so that it would present the kind of stuff that people had shown us they were interested in. So we were just like really happy. We launched it with some fanfare, and it was a total flop, just absolute disaster. So if you looked at the engagement numbers, nobody cared. So why not? So we did a bunch of analysis on that, and we basically came up with two fundamental problems. So first problem, gosh, I just can't find news on the internet, said no one ever, right? So this was not a problem that sellers actually woke up every morning and said, I wish someone would solve this problem for me. Okay, so that would have been probably good to figure out before we built the feature. The second thing that was the problem is that we were presenting all this cool stuff in this neat area in our product, which if you happen to think of it and went there, would tell you some fun information. But if you're a seller, what do you spend your time doing? How do you make money as a seller? You make money by talking to human beings. You talk to them through the phone, and you talk to them through your email client. When you are about to do that, do you say to yourself, wait, I will pause, I will go into this tool, I will find this area on the off chance that it might tell me something interesting? No, of course not. And so what the problem was that the insight wasn't at what I call the moment of action. If you're going to take ML and you're going to make someone's life better, figure out where they do something that you're trying to influence and insert the ML there. Don't put it in some other place they have to remember to go find it. And so that was a really key insight for us, is this concept of moment of action. Okay, and then some discoveries are, for example, it turns out that one of the challenges in understanding how content's used in the sales process is that sellers change it. So let's say you're a marketer, right, and you build a deck. And you've cast it forth onto the waters, and it floats out to your sales org. What do? Well, they promptly start fiddling with it, right? Because they start adding stuff or changing stuff or messing with it. But in most content management systems, as soon as anybody touches a piece of content, it's a new piece of content. So you just lost all insight into that, to that piece of content. And so what we did was we built this really nifty engine that basically could figure out that this slide was actually derived from this other slide that you had built. So you could not only look at how your content was doing, but you could also look at all the derivations of your content and what it was up to. And that was something that had never occurred to us until we really got into the middle of it, and people were saying, but wait, my statistics that you're giving me are not complete because they don't have this information in it. So a lot of stuff that you're going to figure out is actually really leveraged. You're not ever going to be able to figure out a priori. You're only going to figure it out as you go through, and you're going to figure it out because you're talking to your customers and they tell you. So it's really, really important to have that close relationship so that when somebody says, boy, this would be a lot more useful if only, you're actually hearing that and it's not just being lost into the void. Okay. Another thing that we learned, which I thought was really interesting, was pretty counterintuitive to me. So as a properly trained, computer scientist, I knew how to build scalable systems, right? The way you build scalable systems is you create abstraction barriers. You make sure that different parts of the subsystems know as little as possible about each other so that you can modify them and evolve them. You put little containers and things. You have state management so that you can replicate things, right? All those great principles. And that's all like very sound kind of system design strategies for building scalable systems. The problem is it's actually fundamentally at odds with what you want to do in machine learning. Because in, for example, search, what you want to do is you want to say, okay, before you throw up the SERP with all the search results, I want to reach in there, I want to grab what's going by, I want to look at it, and I want to see what are all the inputs, what were all the decisions you made, how did you decide to rank everything? And so if you chop everything up into all these little buckets, there is no single place where all the data that you need to actually make the decision and potentially fiddle with it. Because one of the things you do in machine learning is you tune the algorithm by reaching in, grabbing the data, looking at it, messing with it, and shoving it back in. So for example, if you're doing synonyms, you might take the query plan out, you might insert some synonym stuff in the query plan and shove it back into your system. But if there's no place where you can grab hold of the data, then it's really hard to understand what the system's doing and optimize it. So I coined this term, class pipes, the notion being that you actually find places strategically in your system where you expose and make transparent what's happening so that you can watch the data fly by, all the data, reach in, inspect it, play with it, understand it better, and fiddle with it. And so that was an interesting thing that had never occurred to me about how you want to make sure that you're not preventing your machine learning from working when you do your system design. So that was another kind of cool finding. Another thing is, in the enterprise at least, often your big data isn't very big. So as I said before, since we're talking about humans acting with humans, the amount of data that they generate is actually very manageable. And you can stick it all on a laptop, throw it in Postgres, and fool around with it. And so the fact that you could have basically all of the interesting data in a Postgres database, you can write queries against it, grab it, graph it, throw it in, write Python against it, build a data frame, throw it in there. That just made the data so much more malleable. And so one of the things I would caution people is, in the enterprise especially, don't bite off the whole Hadoop, parallelization, distributed this, super high scale that, industrial strength the other, if you don't need to, because it's so much faster and so much more efficient to just throw everything on your laptop and be able to do it all on a single node. And it turns out for a very long time, you can do that. And so take advantage of that fact because it's so much easier and more efficient. So just one kind of cautionary lesson. So to kind of wrap things up, so I can leave a few minutes for questions, ML can be magical. It can deliver magical value to your users, and it can deliver magical value as a business. But in order to tap that magic, you have to do some key things. You first have to make sure that you've picked the right problem. You have to make sure that you have the right data for solving that problem. It's got to be enough data, clean data, good data. You've got to find the leveraged places in your design where you can surface that insight to a user in a way that it makes a difference so they care about it. You have to have the right tools and algorithms so you can constantly iterate and refine and learn. And if you do all that, then you can deliver a really amazing solution to your customers that they love and that then is the engine, the fuel that drives your business. So with that, I will open it up for a couple minutes for questions. Yeah?
So you mentioned that in some cases it's good to not theorize too much and instead go with the basic algorithms and start doing more variables. If you're in a situation where you already have the basic algorithm running, do you think that's still a good approach, or do you think it like a little bit?
Yep. So just to repeat the question, so I made a big play for the fact that the better data is more important than better algorithms. But the question is, okay, let's say you've got your basic system running. What about those algorithms? Should you continue to ignore them? And the answer is absolutely, you're right, that once you've locked it in, once you're sure you have the right problem, once you're sure you've got a design people care about, once your algorithms are running, your data's clean, you're getting good results, you're measuring it, people are using it, then optimize the heck out of it, but not before. Premature optimization is the root of all evil. And one of the things that people often do is they get all excited about fancy algorithms before they know if there's any gold in there. If there's gold, then get smarter about how you mine for the gold, but make sure there's gold in there first before you do that, is my advice. Yeah?
So you mentioned the sparseness of enterprise data.
Mm-hmm. Yep.
Were you ever to kind of start looking at enterprise data across different enterprises and potentially see some benefits out of that?
Yeah. So the question is, can you look at federated data across multiple enterprises? And so the answer is sometimes. And there's two challenges that you have to deal with. One challenge is confidentiality, and so you have to make sure that you're rigidly, unyieldingly adhering to whatever brand promise or customer promise you made to about what you will and won't conflate. So you have to be super careful about that, and we are religiously careful about that because we do not want our customers to ever doubt that we're keeping their data safe. So that's one key thing you have to factor in. The second key thing you have to factor in is that different enterprises can be very different. So, we have a customer, we have Twitter as a customer, we have Siemens as a customer, and we have, tiny little companies with 50 sellers as customers. So there is some commonality across those three. So for example, when all of them share a video with a customer, it's interesting to know where's the drop-off point in engagement of the of users or whatever. Like there's some things that it doesn't really matter, or, I mean it matters a little, but you can generalize. But then there's lots of things you can't generalize. So for example, Fiserv has an 18 to 24 month sales cycle, right? Lamar, who's a billboard company, has probably a 20-day sales cycle. And so the way that you can look at those engagement patterns, because those go-to-markets are so radically different, you have to be super careful about generalizing. So yes, sometimes, as long as you're rigidly, faithful to whatever confidentiality issues you have to adhere to, and you're very careful about the fact that there's a great deal of heterogeneity across different businesses. Other questions? Yeah.
Do you have any tips for how to motivate teams or even structure teams when it comes to that right data? So nobody wants to do the basic algorithms, then definitely they don't want to do the data cleaning.
Yes. So how do you motivate people to do icky, boring stuff like data hygiene? Yeah, it's a challenge. I think that I'm going to give you kind of a sort of a general answer, but it is my answer, which is you want to help them understand why. So, the old parable that they always give at business schools about, you ask the one person, what are you doing? And they're like, I'm making a brick. And you ask the other person, I'm making a cathedral, right? And it's a little hokey, but it's still kind of true. If you don't help people understand what is the greater good that this boring, irritating activity that they're doing, accrues to, then they're not motivated. But if you can get them to see that, wow, there's this really amazing experience you could create in the product, if only we could bring together all these disparate forms of federated data into a unified place where we have a nice clean schema that we can then reason about in a powerful way, I think that's the best tool to motivate them. At least that's the one I've found works best. So, great. All right, well, thanks, everybody. I hope you got some good ideas.